Okay, here we are looking at the second part of 4.2. I thought I'd break this section down into two as well, just so that it's a little more digestible. Here we're just going to be talking about graphs of log functions, okay? Hopefully you watched the first one and you remember that they are inverses of each other. So if you look at a graph here and we had an exponential function, say 2 to the power of x, it's going to look something like this. It always goes through 0, 1. We'll look at that in a sec. Boom, it goes up like that. Okay, inverse means that you have a reflection around the y equals x axis. So what's going to happen is you're going to have a graph that ends up looking like this. Okay, so if this is y equals 2 to the power of x, then you're going to have this being x equals 2 to the power of y. Now we looked at how converting this into logarithmic form, because they're both functions, means that you end up looking at something like this, where you solve for y again. Okay, so notice that in order for these to be inverses of each other, they need to be one-to-one functions, right? And that's the idea. The original function exponential is a one-to-one function, which means that the inverse of it, the log function, will also be a function, okay? Or the log graph, logarithmic relation will be a function. So what we're going to look at here is a few things. So the inverse of the exponential, so it's a flip over the x equals y axis, right? Now I gave you a quick graph there. What I'm going to do is give you a pretty graph here. Ooh, and everybody go, ah. Now, so flip over the y equals x axis, x equals y, whatever. I don't know why I wrote x equals y there. It doesn't matter. Funny, haha. So now the exponential function, let's look at a couple things here. Okay, first of all, there's a horizontal asymptote, right? That asymptote is at y equals 0. So let's put that up here, maybe y equals 0. That's the horizontal asymptote before any transformations, okay, obviously. And they all go through 0, 1. So boom, 0 and then up 1. They all go through that point, and you understand why, because if x is 0, anything to the power of 0 is 1. Again, that is only if they are untransformed. They are in their original unadulterated positions, okay? Now let's look at the domain and range for these things. So the domain here, obviously, maybe not obviously, but it's going forever this way, and it's going forever this way. It means that your x can be all real numbers. Your range, however, has to be greater than or equal to 0, okay? Because it's all the y values, and nothing exists below the x-axis, and it can never be the x-axis because the x-axis is your horizontal asymptote, okay? There you go. So now, exponential or logarithmic functions. I think you can probably see both of these things. First of all, if you had a horizontal asymptote at y equals 0, now you have a vertical asymptote at x equals 0. Ho-ha! Y becomes x, x becomes y, okay? So boom, there's your vertical asymptote now at x equals 0. So the logarithmic functions all go through 1, 0, which is essentially the inverse of this. 0, 1 becomes 1, 0. Boom, bam, there you go. And all your points get inversed as well. 1, 2, 2, 1, right? 2, 4, 4, 2. 3, 8, 8, 3. Boom, okay? They all get reflected. Now the domain and the range. Well, look at the domain here. Now the domain starts at 0, so your x has to be greater than or equal to 0. That used to be your y, now it's your x. Look at your range. It used to be your x, now it's your y. So your range is all real numbers now. Okay? So exponential function, bam, boom, bam, bam. Logarithmic function, bam, bam, bam. Inverse of each other. Now, a big thing here. Okay, domain of an exponential becomes range of logarithm. Range of exponential becomes domain of logarithm. That's kind of what I just showed you here as well. Okay, pretty much done here. Showing you the log function, graph of the log function. Last thing I want to say is that the transformations, just like always, are the same in as they are in every single other function that we've looked at. Okay, so if you're going to take this thing right here, and you're going to write down something like this: y is equal to log base, I don't know, 2 of x minus 3. You look at this thing here, and what are you going to say? Well, you've changed the x. You've got a minus 3 on the x. It's working directly on the x, which means it's a horizontal shift of some sort, right? like we've known before in the past, this means that it's gone right 3. So what happens is that your horizontal or your vertical asymptote goes right 3. Boom. So now this is my vertical asymptote. It comes down, it goes through 1, 0. There's your log function. Okay? You can add 2 at the end, which means that this every point goes up 2. You could stretch it a little bit here and there too by putting a number in front right here, or in front here, or a number in front here, which would be on your y. So the transformations, ladies and gentlemen, work exactly the same way. You're not going to get them unless you understand what the original functions look like, as it's always been. If you know what the original function looks like, then the transformations shouldn't be a problem. All right. Hope that helps.